I think we are good to start. Well, welcome. This is the tutorial about visualizing the 2019 measles outbreak here in New York City using Python. And so I already mentioned the repository, but I'm going to try to make this more interactive here in the live tutorial. First, I'd like to thank everyone involved in organizing this event, and also thank you for selecting my proposal for this tutorial. Secondly, I'd like to thank the New York City Health Department for making the measles data available. It's actually, from all the areas that had measles this year, from what I could find, was the jurisdiction that provided the best data. Even though it was just raw tables in a web page, it was still very good. And so a couple of disclaimers. This is a personal project. It's not associated with any company or any employee. I'm not affiliated with NYC Health, so I believe I captured the data correctly and I'm visualizing it correctly here, but it's possible I did some mistakes. If that's the case, it's my fault. It's nothing to do with NYC Health. And of course, this is not for medical advice. And so this tutorial notebook is verbose, and that's intentional for someone who may be following it outside of the conference. And here I'm going to try to make it more of a discussion, more interactive. And feel free to ask questions anytime you don't understand something, or just have questions about what's going on. All right. And by the way, my name is Carlos, and I'll give a little introduction about myself. But first, a summary about what we're going to do here. First, the context. As a general goal, this is kind of a good example of a small project, a small data project that can help the community where you live in understand an important issue, which is the case of the measles outbreak, which is important locally here. It was actually important at national level because many other places had the outbreaks. So this year, the US is amid the largest measles outbreak since 1992. And the measles had actually been declared eradicated in 2000. So you can see how bad it is. It goes back to before the disease was eradicated in 2000. At the moment, there have been reported 1,250 cases as of October 3rd in the whole of the US. And most of those cases, actually about half of those cases, were here in New York City. And fortunately, the outbreak was declared over on September 3rd, meaning there's no ongoing community propagation since, well, on September 3rd, they declared the end of the community propagation. So there's been no more cases so far. So the goals of this talk, the general goal is to discuss and show how to create visualizations that help understand the outbreak. Some very simple visualizations like bar charts, and some more advanced, I would say, like the bubble charts on the map of New York City. And those are the specific goals is to create that bubble map and those bar charts using two Python libraries, bokeh and matplotlib, and we'll follow principles of, I called here, clarity and context to make it as easy as possible to understand and as clear as possible to understand what's going on. Okay, and so these are our final products. So we're going to be creating this bar chart about the New York City measles cases by months, which shows the progress over time, and this map of New York City showing all the neighborhoods that had cases and the number of cases in each neighborhood, and also the names of those neighborhoods. And I'll explain why I took the decision of showing the labels, even though it may make the visualization a little cluttered. Basically, it's because, well, I'm fairly new to New York City, and when I first learned about this, I'm from Williamsburg, where most of the cases are. I live in Williamsburg. And when I first looked at this and I looked at the list of the neighborhoods, I didn't know where they were. So I imagine for people who are new to New York City, it's difficult for them to know. And I imagine maybe even for someone who lived here for a long time, may be difficult to know where some of those neighborhoods are. Would you know where those neighborhoods are if you didn't see it in the map? So that was kind of my trigger, my initial motivation. And we also be creating these bar charts, these horizontal bar charts. So these are our final goals. That's what we are working towards here. Okay, so a more proper introduction. So my name is Carlos Afonso. I'm originally from Portugal. That's the reason for my name and my accent. I'm passionate about using data science to solve important problems. I have a diverse industry experience and a background in STEM. As I said, I'm originally from Portugal. I first studied physics. I did a master's in physics engineering there. I ended up going to Oxford doing research towards a PhD, which I ended up not finishing because I moved from academia to industry before that. And in the last 4 years, I've been doing corporate consulting, solving data science problems for a variety of clients and companies in different industries. So more recently, I created this Measles project, and I would be happy to connect with you guys on LinkedIn. Okay, so let's go back to what motivated me to do this project, and what may be your motivations to look at this project and what you can take from it. So as I said, my initial motivation was that I live in Williamsburg, where most of the cases were happening. So I have a background in biomedical engineering, so I was curious about it, and I started doing research, and I noticed that the New York City Health Department provided the data on their website, but the data is just some raw tables. I'll show you in a moment. And as I said, the neighborhood situation, I looked at the list of neighborhoods and I didn't know where they were. Now that I show you just, for example, these 4 neighborhoods, without showing the map, do you guys know where those are? Yeah. So the technical and practical motivation is that this is was, I think, a nice opportunity to learn, practice, and actually showcase data skills, fundamental and advanced data skills. In particular, data visualization projects are very good to showcase your skills, like to other people, to recruiters, and so on. So that's a practical motivation for this project too. And as I said, on the background, the general motivation is that this is a good example of how you can, even a small data project can help your community understand an important subject, and even at this case was a national-wide subject. So still on the introduction, as with any data science project, it's important to understand the background, so you can better understand what you are doing and why you are doing it. And it's going to be important to understand what Measles is, to know what visualizations to create and how to represent them, and what information to provide in those visualizations. So Measles is a very contagious disease it's caused by a virus, and is transmitted by infected people when they cough or sneeze in the air. Fortunately, measles can be prevented with a vaccine called the MMR vaccine, which stands for measles, mumps, and rubella, which protects for those 3 diseases. And the Central for Disease Control recommends that children get 2 doses of the vaccine. But you'll notice that the first dose is between 12 and 15 months of age. So the first point is that newborns cannot have the vaccine yet. You have to wait until they are 1 year old to give them the vaccine. That means that they are going to be very vulnerable in their first year of life. And that's an issue when there's an outbreak going on. So you imagine yourself with a newborn living in a place with ongoing measles outbreak, and you'd be concerned every day. And then the second dose can only be taken between 4 and 6 years. So even after you take the first dose, the baby gets the first dose, he has to wait until 4 years old until he can get the second and get the most protection possible. Indeed, the 1 dose is 93% effective, and 2 doses increase the effectiveness up to 97%. And just to wrap up the context about measles, so a brief history of the measles in the US. The vaccine was introduced in 1963, and before that there were lots of cases and lots of problems with measles. So it's estimated there were about 3 to 4 million cases. Of those, only about 500,000 would be reported to the Central for Disease Control, and from those that were reported, 400 to 500 would die. So this is like 50, 60 years ago, and people were a lot of people are dying because of measles. In addition to that, there were like 50,000 hospitalized and 1,000 developed brain swelling. Fortunately, since then, the vaccine has been a great success, reduced immensely the number of cases by more than 99%. And as I said before, in 2000, the measles was declared eradicated in the US. However, there are still measles in other countries, so when people travel to the US who may have measles, or people from the US travel to those countries and they are not vaccinated, may acquire measles and then come back and transmit to other people who are not vaccinated. So that's actually the most common case of how the outbreaks still happen in the US, and it was the case this year as well. So as I said, this year is the largest outbreak since 1992, and with 1,250 cases, and about half of those cases were in New York City. That's why we are focused in New York City, and also because that's where we are living at the moment. And also because New York City is actually the one that provides the best data. At the time, I looked at all the areas that were having the measles outbreaks, and they have little or no data. And I'm going to show you the great data that's available from the New York City Health Department. So you go to their measles webpage, they have lots of information, and then they have this part where they have the data tables, and they show the cases by neighborhood, the cases by age, and vaccination status. This is a matrix. There's a kind of matrix information here. I use only the totals, but there's potential to do more visualizations by doing a visualization of this as a matrix plot, for example. But that's a secondary. I focused on the main factors at the moment, and the cases by date. So this is really great that the New York City Health Department provides this information. No other area that I could find provides such good data. So it's really good. Okay. So these were just screenshots in case I couldn't load the website. Because the data you saw is very small, basically I just collected it manually. So I just went to the page and typed it in Excel file and saved it in CSV files. There was a stage in the middle of the outbreak where the data would be updated about once a week. So I was saving different versions of the data so that I could see the progress and so on. But I'm not going to be talking about that stage because we are now at the outbreak was declared over. So we kind of have a final version of the data, given that there are no more cases and they don't reopen and start increasing the counts. So the final version of the data is more clean. There's only a version. But the GitHub repository has other notebooks that deal with the fact that the data was changing every week, and I was collecting the data manually as well, and keeping all those different versions. And something interesting I found is that if you miss an update, you can try to find it on the web archive. They take screenshots of many websites. And I could find several versions, past versions of the data by going to the web archive. So this was useful for this case, and it can be useful for other projects you may be working on, where you find the web page with data, and the data is updated every once in a while, but you weren't there in the past. You can go to web archive and try to see if they have screenshots of that website from the past that you can use to collect more data. All right, and so we are. Did any help?
Sorry, you can go ahead.
No, I can help you too. That's what we are here for. All right. So I collected this data and I saved in CSV files. But I just want to show you here how the data looks like, and it's very simple. So just going to use pandas to open the data that already is stored. And here you can see this is the data by age. And you have the data for the age group for kids under 1 year old, the age group of kids between 1 and 4 year olds, and 5 to 17, and 16 and over. I also captured the reported total and the start and end date. So I always kept the dates to have that context information. So when you see a visualization, it tells you when that data was collected from. And the same for all the other data tables. You can load them all as pandas data frames and work with them. So and I'm gonna be showing each of them in more detail as we create each of the visualizations. Okay, so now it's when I'm gonna start running some more code. Any questions so far here? Okay. So the first visualization is going to be the number of new measles cases by month, which gives you the idea of the progression of the disease over time. And technically, this is an example of the simple vertical bar chart. But I did several changes to the default, so I'm already showing here the final outcome of this. So if you just do a bar chart on matplotlib, you get the default, which is this one with the blue bars. And I did several modifications to try to make it more clear and provide more information. So can you guys tell me what I removed or added? What are the differences? Let's spot the differences. What? The color. Okay. Does anyone know why I changed the color? Do you have any idea why I changed from blue to reddish? Because it's bad, actually. So with measles, you get a reddish colored rash on your skin. So to give an impression of the problem at hand. And of course, and red is also indication of bad. Yeah. So the color. Any other differences?
Added numerical labels to the bar.
Yeah. Added the number of cases on top of each bar to make it clear what were the exact numbers.
The horizontal axis is prettier.
Yeah. The horizontal axis prettier and hopefully easier to read and to understand.
You remove the axes themselves, the lines.
Yeah, I removed the frame. And the left axis, yes.
And you added that final line.
Yeah, let me try to, it was too much magnification maybe. Yeah, now you can see it all. Yes, and I added some lines. What's that for?
So you know what you're looking at.
Yeah, and to provide additional information and context. So I'm telling you there what's the total number of cases, what's the time frame in which the data was acquired, which in this case is implicit in the graph, but the others not necessarily. There's an important line there saying in April 2019, New York City increased its vaccination efforts. And when you look at the map, you could at the plot, what you see happening in terms of the evolution of the disease. How would you describe what happened in terms of number of cases over time?
Exponential growth and decay.
Yeah, and when did this change happen?
After they introduced the vaccine.
In this case, the vaccine was always here in New York City. Yeah,
Increased the effort.
yeah. So they in April they took strong measures. Actually, you may have seen in the news. People could get fined by not getting disease. So they changed they implemented the rule where they were really pushing forward for people to get vaccines. Was a little polemic at the time because they were threatening people with fines. But this is not a causal confirmation of that they did cause the outbreak to end, but it's a good indication that the actions they took in April helped end the outbreak, because after April, the number of cases decreased drastically and progressively until August. There were no more cases. And then after that period without cases, in September 3rd, they declared the end of the transmission. So again, if I didn't tell you that in April there was that action by the New York City Health Department, you'd be missing an important point of information, which indicates you at why in April things changed. Again, it's not a causal explanation. This data is not enough to tell that was their actions that led to the end of the outbreak, but it indicates that their actions helped contribute to the end of the outbreak. All right. Any more differences you can see there?
Well, you increase the title font.
Yeah.
And also widen the bars, but still kept a break between the bars.
Yes. So I increased the font all over, so it's easier for everyone to see. So when I created these visualizations, I tried to make them so that they would look nice on the laptop, but also on the phone, because nowadays a lot of people just look at stuff on their phones. So that's why I make the font big. Okay, so let's look now at how that actually you guys went through all over the notes that I had here, and now I can show you the exact code and run this. So let's see if I can increase magnification, and feel free to ask questions if you have any questions about the code. So my approach was I created individual Jupyter notebook for each of the visualizations that I created. There was a lot of duplication. I could have tried to do all the visualizations in one notebook, but as the outbreak was going on, I was trying different things. So it was easier to keep things modular and separated. So for each visualization I created, I would have a different notebook. And this is the notebook for the number of new measles cases by month, which is that plot I showed you over there. So let's run this just to make sure. Let's start a new kernel. So the libraries, you can see the most important library here is going to be matplotlib to do the visualizations. We load the libraries. As I said, the data was collected from the New York City Health measles webpage. I collected it manually, saved in a CSV file, and now I can load it. So and these paths are all relative paths, so it's designed to work when you guys also download the materials in your computers. It should work without having to do any change. So we're going to read the data, and so here we have the data. We have information about the start and end date of when the data collection happened, and we have the first month of September 2018 goes until the end of the last month, August 2019, and we have a reported total number of cases. So to create those visualizations I showed you, we want to provide more context information. And here we're gonna extract the start date and end date. Initially, I was reporting the start date and end date with the precision of the day, but because some of these visualizations only show the months, I'm now showing just the beginning, the start months and the end months, and that's what's happening here. I'm getting the start months and end months from the start date and end date. So this lambda function, what it's doing is that it's operating on these dates. It's reading this format first, the year, month, day, and then transforming it to months space year as a string, which is going to be the string that I'll be using to provide those additional notes on the plot. If we wanted to provide the exact day, we could also provide the exact day, but it's too detailed, and it's not necessary in this case. So we also want the number of total cases to be displayed as information in the plot. We have the total cases here in the final column, and that's how we are collecting the total cases. And actually, I'm checking that the total cases match the sum of the individual months. So I always check the data that I was collecting from them. And during while the outbreak was going on, I came across a few mistakes, like the number of cases would not add up to the reported total. And actually, I told them, I sent them an email, and they were kind enough to reply, and they corrected on the website. So it's always good to check that the data is correct. And in this case, it's a simple check. If they report the total and they report individual parts, just do the sum to make sure that what they're reporting adds up. And in this case, it does. If it didn't, it would give me that warning message. And because it does, it just doesn't give me anything. And I'm selecting the exact data to plot from the data frame, which is just the data we actually be plotting on the bar chart is the months and the cases from the September months to the August 2019. So that's what I'm extracting here now. Again, I'm using index references to the pandas data frame. If you guys have any questions about that or any other questions, feel free to interrupt and ask questions. So again, this is the data that's actually going to be plotted. And those nice labels you saw there, this is how they are being created. So first I get all the months labels from the column names. So I get all these all these strings first. And then what I do is that to not repeat the year, because that will become very repetitive, I only provide the year in the first month and the last month. And actually, if there's a transitional from the one year to the other, I also provide it in January. So that's what this code is doing here. And I do new lines so that you have the months, and then if you want to display the year comes out below the months. So it's easier to read, and you can do a vertical bar chart with labels that are thin enough to display and have spacing and be easy to read. So these are the month labels you get is September with a line break 2018, then January is a new year, line break 2019, and the last month is August, line break 2019, and the rest are just the months. And so for contrast, I created here what was the default bar chart from matplotlib without doing any modifications. So that's what I showed you initially. So this, and again, you spotted several of the issues, like in particular the x-axis labels are difficult to read. So I saved all these plots as images so I could present them in here in the tutorial and also in the project webpage. So at the end I'll be showing you how I present all these visualizations in a GitHub page. So it's live there, everyone can see it and read it. So, and to save the images, I save them both as PNGs and SVGs. Ideally, it's better to use SVGs because it's a scalable format, does not lose any information. But sometimes, in some places, it's difficult to use SVGs. That's why I also save PNG versions. And here's where I'm creating the improved bar chart with all and explaining all the changes I'm doing to the default to make it look better, which were all the changes that you already spotted. So I think we can skip this information forward. So I also changed the font type because Arial is easier to read than the default one. So I established a base font size, which I'll be increasing or decreasing as needed. So in the title, for example, I use a font size that's four points higher than the base. So that I'm adding the title there. This is just the line to create the bar chart. All the other code is to improve it. So as someone spotted, I removed the y-axis. I removed also the x-axis ticks only. There were like some little lines there that didn't provide any help. So here's how I set my defined labels. And this code is what sets the number of cases on top of the bars. If you guys have any questions about any particular code, let me know. So this removes the frame around the bar chart, and this adds all the textual information by using the information that I collected before, the total number of cases, the start months, the end months. This line is kind of hard coded, and this line as well, because this information does not really change, at least within the current final version. And information about the sources, the data comes from the NYC Health, and this image is always available at the project homepage in case people want to go there. And I used a different font here, with a monospace font for the information about the sources. Okay, and that's how you get this visualization in the end. So there are a lot of changes there, and when you do your visualizations, you may want to use some of them. Others don't. But I hope this can be helpful when you do your visualizations. You can just take some parts of the code to depending on whatever you need. Again, we save this visualization as PNG and SVG, and for all the notebooks, I like to save them as a HTML. For example, when you are on GitHub trying to load a Jupyter notebook, sometimes it takes a long time or doesn't load it. So if you have an HTML version, you can just also provide people the link to the HTML version, and it opens much quicker, much more quicker. And if you don't have internet, and I'm doing this presentation without internet, I'll at least still and I'm having problems with Jupyter, I could still do this presentation with just showing the HTML versions, which is basically a printout of all of these with all the images. So I think I always find it useful when working with notebooks to print a HTML version of it. Okay.
Thanks for the tip.
Yeah, and this is the simple line you can use to do it. Okay, so that was this example of a vertical bar chart that in this case showed us the progression of the disease over time and highlights the fact that in April there was this push from the New York City Health Department to increase the vaccination efforts, and then the months after that the number of new cases decreased, and then in August. So now I have three more visualizations for you to show you, which is these horizontal bar charts, and the final one is the map. So I just want to check on time, how much time I have left. Okay. Do you have any questions so far?
Yeah, so you did a lot of font changes. Like, I understand making things bigger. You also did a lot of changes in the style of font. What was your philosophy around which font?
Yeah, when I was doing this, I was creating them and then looking at them on my laptop and on my phone. I have an Android, and then on my wife's phone, who has an Apple, an iPhone. So I tried different things, and I stopped when I found something that looked nice everywhere. So that's why I also changed the font type. Arial seemed to be a good font to display on your screens. And when you look at the phone, it's really difficult to provide so much information and be able to read it easily on your phone. So that's why I increased the font and changed the font type. And I tried to make the visualizations kind of taller than wider, because the phone screen is tall, it's not wide. That's a challenge with the map of the New York City, because the area where the measles happened kind of comes out as a square. There's not much you can do. You could try to stretch it, but then that distorts the map. Yeah, so that one is a little difficult to see on the phone, and so I had to balance. See, the size of the bubbles there are as large as they can be without touching each other. The Sunset Park and the Borough Park, these ones are almost touching each other. And then the numbers are as large as they can be without coming out of the bubbles. And the labels are the same size as the numbers, and also they couldn't be much larger, otherwise they would be overlapping each other. So it was a lot of trial and error, and looking at the devices where people could be looking at this. The laptops are very easy, but phones are very difficult. So you have to try to make it as large as you can, so it's easier to see on the phone, and try to make it taller rather than wider. All right. Any more questions? Yeah.
So which parts were bokeh instead of, like, I'm familiar with matplotlib, but
Oh yeah, it's the map. The bokeh is the map. Matplotlib are the bar charts.
oh, I see.
That map. So for the map, I tried several things. Like I tried Google Maps, but then you have to have this API, and then I was seeing examples of people online where they had created something, and when you go to their website, it said not available anymore. So I didn't want that to happen, and I couldn't quite do this on Google Maps. So that one was soon eliminated. The one I used just before this was Folium. It's another library where you can do maps, and that worked well. The issue was saving the map I created as an image, like as a PNG or SVG that I'm doing here. I couldn't quite make it work, so I couldn't quite make save it to a nice format. I had to save it as an HTML file, the map I created on Folium, and then I was manually taking screenshots of the HTML file. So I would open the HTML, take a screenshot, and then crop it. So it was not as easy as with bokeh ended up being. So that's why I'm using bokeh. The main reason is it lets me do everything I need. It's always going to be there, and I can easily save what I create as an image, a PNG image or SVG image. There is an issue. That's what I'm showing here. The SVG image does not load well into HTML pages. That's why I use the PNG, but we can get there. And any more questions?
So I have the issue often with the notebook not rendering on GitHub. I fix it.
Mm-hmm.
I've identified it as a GitHub problem. So it's like 2/3 of the days it's just random. This exact same notebook will render sometimes and other times not. So when you save it HTML,
it always opens.
on the GitHub,
Let's see.
I can't view that HTML page, right? So how would I tell someone to view the page?
All right.
Not a web server.
Let's see. Actually, I should be looking at the ones. So I created this folder where I'm going to keep this PyData NYC 2019 folder, where I'm going to try to keep this as a static version of what I showed here, while I still keep working on the rest. So I'm going to try to come back and try to show you an example from here. So let's see what happens if I click here. Okay. That does not show as HTML.
It's not a web server.
Mm-hmm.
I do have a website that I can just, I guess,
Yeah.
post
So
all the HTML pages.
I do have the final presentation page, and I can point people to the HTML through this page.
If you git clone that repo and then you just open that HTML link in your browser, it'll
Yeah.
come up.
Locally.
Yeah, locally.
Right, I'll just download one page and try that.
Yeah, that works for me.
So I'm going to talk about these at the end, but I think these, there you go. So this is how you do it. This is the HTML version of one of the notebooks, and there's a link for it, and I can do that because I set up GitHub pages on my GitHub account, and it's easy to set up. You can just follow the instructions from GitHub, and when you set it up, you get like your home page, github.io, and then for every project you create, you get a page created immediately as long as you allow that in the repository. So you'll see here that this is my name, my github.io account, / the name of the project. Oh, you cannot see that, / Measles. So this is a good way to point people to the HTML version. So this is the github.io, kind of like your own GitHub page. And then for each project, you just need to write / the name of the project. And then you can write the path to the HTML version of your notebook, and you'll be able to see the HTML version of your notebook.
Okay, I see. So,
Yeah.
so you're using the default GitHub
Pages.
web
Yeah.
server.
Yeah.
So
Yeah.
I didn't realize it had that default, so you can just render all the HTML pages in the GitHub repo.
This one works for me. We're using the GitHub pages. Yeah. Yeah.
So how do you, what do you set in the repository for it to know that it should redirect to that repository? So /measles. So you do something in the repository, right?
Yeah. You just allow GitHub pages to build a page for that repository, and that's it.
So the page that we see when we go to your name, github.io /measles, is the README.
And it can be the README, but I changed it to be an index. I wanted to have a different README because the README has all the instructions for you guys, and I want this page to be kind of the project landing page for anyone who is interested in learning about it and not particularly interested in the code. So in the repository, I have the README, which has all the instructions for this tutorial and the requirements, the package requirements, and I have the index, and the index is the landing page for the project with the nice text and the nice images. Here, yeah, the rendering here is not as nice, and we'll actually go to the page, but that's why I did it.
So whatever you like set in the index MD will be shown as the landing page, right?
Yes, yes. If you don't, when you create, if you create just the README MD without the index MD, it will show you the README MD. So if you want to overwrite the README MD, you can just create index MD, and that will be the one displayed. Yeah. Any more questions at this moment? All right. So I would like to show you a similar example, but with a few additions. In this case, it's an horizontal bar chart, and there's an additional element of displaying the percentage of the cases. So again, let's play. I already gave the answer. Let's play the spot the difference. In this case, we are showing the number of measles cases by age group, and on the left-hand side, you have what you'd get as a default bar chart on matplotlib, and on the right-hand side, it's kind of my improved version of it. Can you guys tell me what differences do you spot here?
Transposed?
Yeah, so it's a horizontal bar chart instead of a vertical bar chart. Yeah. Why do you think I used the horizontal instead of vertical?
Because we read that way.
Yeah. And the labels are kind of long, so when the labels are small, like the months were in the, sorry, like if the labels are small, like the months, it's easy to do on the vertical bar chart, but when the labels are long like these ones, it's better to do a horizontal bar chart.
And it's not time we associate left to right, just the way we normally see it.
Yeah.
It's time.
Yeah.
Those categories.
Yeah. That's a good point too. Any other differences? So it's horizontal instead of vertical. I think someone mentioned the percentages. So here, these four categories make it add up to the total. That's why I'm giving the percentage. So in addition of showing the number of cases, the percentage is useful to highlight the group that's more affected and by how much difference. So you can see that the group that had more cases were the kids between 1 and 4 years old. It was 277 cases, but it's helpful to see that's 43% of all the cases. Here they are kind of similar, but still it's useful. It's particularly useful, I'd say, when you go to the number of measles cases by the vaccination status of the people who got the measles, and it's quite impressive that most of the people, like 73%, weren't vaccinated, which is kind of expected. People who were not vaccinated are the ones that will get more of the disease. But okay, so coming back, we have the horizontal bar chart, we have the percentages, and again, we have all the other differences that we already spotted on the other, on the first case of the vertical bar chart. So I'm just gonna, again, run this. Can close that. Start the kernel to make sure. Okay, so this is going to be. So even though I did different notebooks, there's a lot of notes and code shared. It's very similar. So I'm going to show you. Just load the libraries. Again, we're going to be using matplotlib. We read the data the same way we read the data before. Just now it's the number of cases by the age group. Again, we extract that context information about the start months and the end months using the same code. The total number of cases, again, using the same code. We extract the data to plot, which in this case is the categories of the age groups and the number of cases for each age group. And as before, we create like the default matplotlib bar chart. and now we're gonna do we're gonna save that. So we have to show we have available to show in the presentation, and then you already mentioned all these changes that I did, and the code is very similar. The difference is you use bar h instead of just bar. So
it's invert y-axis to get it to lay over?
oh yes, yeah, that's a good point. I'm gonna do it without this, without the invert y-axis. So the default was this one, and I found it easier to read from top to bottom, as like starting from the younger age to the older age. I think this would still be valid. Maybe just my personal preference, but I do find it easier to read from top to bottom, and to have that age progression from top to bottom. That's why I inverted the axis. Yeah, that's a good change. Well spotted that difference. It was not the case in the other one. Okay, so now we invert the axis, and that's how you get the inverted order. And what's new here is this creation of the percentages, which is done with the following code. Here. Okay, so it's kind of the same code as we used before to just add the number of cases as labels, but now in addition to just the number of cases, we are also adding this string, which is going to show us the percentages, and we are running the percentages to the nearest integer, so that if you don't do the rounding, you'll have decimal cases, and then it becomes cluttered in the graph. So you always want to provide useful information, but hide unnecessary details like the decimal points that would clutter the graph. So that's why we are doing the rounding there. And this is the exact code that is providing the percentage information, which is the only thing that changed from the previous one, the addition. Okay? Yeah.
So you have this I.get width in there. That you're reading the numbers off of the chart itself and not off of the data?
Yeah. Yes. The get width gets the size of the bar chart, and that's just to provide the position where to display the text. So I want to display the text immediately after the bar chart. And actually, I'm giving it an extra 5 of spacing so that the labels are not right on top. So if I don't give him the 5, they're going to be right on top, and it's going to be a little cluttered. So that's why I'm giving an extra. Yeah, that's a way for you to get the width directly from the graph. Yeah. Yeah.
Trying to figure out, so that the get width is giving you that length of the bar, and then you're adding a string to it again. You're adding the bracket and then the stuff inside.
Oh, yeah. So the get width will give me the number, which is the number of cases, 102. Right? That's because it's an horizontal bar chart, it's the width. It's more easy to think it's the length of the bar chart on the horizontal axis, but it's the width because it's horizontal. So the width is gonna give you the 102, the 277, and so on. Okay, and then I use that also to calculate the ratio of that width compared with total number of cases, and I multiply by 100 to get the percentage. Yeah, so I transform, the get width gives you a number, and I transform it to a string.
Yeah, you just make it a label. Okay, yeah, I get it.
Yeah, I was surprised that it came from the get width and not from the data itself.
Yeah, because I'm in. I could use it from. I could do it from the data. Yes, okay. But this way I will this way I guarantee that I'm doing it in the right order. Do you remember, I flipped the axes and so on. So then you have to be, if you're going to do it from the date, you have to account for all the changes you did. You'd have to flip the order of the data as well. So this way, you actually accessing the plot as it is at the moment. You are not concerned about what you did to the plot already. All right. Okay. Any more questions here? Yeah.
Can I ask your opinion?
Yeah.
What did you think that there were all these unvaccinated people in New York City?
Well, that's actually interesting question, and so the main reason why people got the trigger was someone from the US went to a country, someone unvaccinated went to a country where there was measles, and they got measles there, and they came back with measles, and they spread it through a community where there were low vaccination rates. So the main reason why people got measles is they were not vaccinated. Okay. That said, measles happened in a particular community. Well, most cases were in a particular community. It was not just that community. If you read the newspaper articles about it, they explicitly name what community that is. So I had that question yesterday for the New York Times presenter when he talked about ethics. So I talked to him, and I don't have the right answer. So my point is, I will not name the community in any of my materials because the data is not available. So even though a journalist can go and ask the New York City Health Department or ask doctors what's going on, and they may tell him, oh, we're finding more cases in this community. There is no data that I know separating the cases by communities or traits of communities, also because I think that's not allowed. You shouldn't be collecting some information about people because of privacy issues, and it's either not allowed, or if it's collected because it's useful, it's not allowed to be public. So I don't know. I'm not expert on this, and because I don't have the right answer, I chose not to mention the specific community it happened, because the main point is not that community or another, because in other places of the country it also happened, and they were different communities. It can happen in all kinds of different communities. So the main point is people were not vaccinated, and that's what I'm trying to make that's the point I'm trying to make here. But yeah, if you read the newspaper articles, journalists do mention what was the main community affected here in New York. But there's no data for that I know of. I think that's because it's not allowed to collect that data or make it public. So as a data scientist, that's actually, you should be aware of the ethical issues. If the data does not exist, it's probably a good hint that you shouldn't be showing it in your visualizations. Because, for example, I could, the same way I write here some lines with providing additional information, I could write most of the cases were in this community. But should you be doing that? I don't have the right answer, and I think at the moment I shouldn't be doing that, because one is not the most relevant information and may distract people from what's important, which is people that had the measles who just didn't had the measles. The main reason was they were not vaccinated. So, and that should be the focus. And measles happen in many different places in the US, in many different communities, and the common factor is that the people who were not vaccinated were the ones who were more at risk of getting the disease, and were the ones that had the disease. All right. Yeah.
Was there any, in the answer to your question, was there any reason cited why that community kept being reported? Like, why did people feel like it was okay to do that in their reporting? Yeah,
so these were like journalists, include like journalists from important journals like the New York Times. They would mention it's a particular religious community, and they would mention it. So journalists know much better, know more ethics than I do, or the data scientists do, and they are very strict on their ethics. So if they do it, it's because they see that it's ethical for them to do. There's benefits on doing it. So it does provide information to the wider community, and it certainly helped it certainly helped the New York City Health Department knowing what was the particular communities that were more affected, and actually they focused their efforts on increasing vaccinations on those communities. So that's helpful information. But here what I'm doing is I'm creating data visualizations of it, and the question is, should I be putting that information in the visualization? I don't know the right answer, and I prefer to be defensive, and because I don't know it, I don't do it. And I think that the main reason was people are not vaccinated. But if you read the news articles, they will mention.
I think here we're just describing basically the what
Yep.
and the why, right?
Yeah.
What's happening, where's it happening, and why those vaccinations.
Yeah.
If you want to then if someone wants to then be prescriptive on what were the root causes for the non-vaccination and how would we go address those, right? That's where the public health department is trying to get into those population issues, which is beyond the particular questions that we're answering with this couple of CSVs that we have.
Yeah. So this is kind of descriptive statistics describing the problem with doing nice, easy to understand visualizations and putting the focus on the main factor, which is people not being vaccinated, which is the common factor across all communities. All right, any more questions? So we have half an hour?
Yeah, about 25 minutes.
Okay, so let's get back to the main notebook. So I showed you that one, the horizontal bar chart, and now the next one is also a horizontal bar chart. The code is exactly the same. Let's just highlight the insight, which is the main point of this descriptive analysis, is that the bar chart clearly shows that most of the people who got the disease, who got measles, were unvaccinated, right? 73% of the cases were on people that were not vaccinated. And there were a few cases, like 7% in people that had the one dose only, and even fewer cases on those that had the 2 doses of the vaccine. And there were several cases that people didn't know their status. Actually, those people who didn't know their vaccination status were adults. Normally, the kids nowadays will get the vaccine or know if they got it or not.
There were no cases of people who had gotten the vaccine, but they hadn't seroconverted. They say every now and then someone, whatever their immune system, it just doesn't work quite right. Say what?
Oh, there were people that had the vaccine and got the measles. So 7% of the cases here in New York were on people that had the 1 dose only, and 5% were on people that had the 2 doses. Yeah. As I said in the introduction, the vaccine is not perfect, but it is very effective. So here, the 1 dose has 93% effectiveness, and 2 doses 97% effectiveness. And so actually, it also depending on your age, you may have gotten the vaccine when there was only 1 dose, or may have gotten the vaccine where there were 2 doses, and maybe you got updated and you went to get the 2nd dose, or you didn't. So there are all those different factors. So when the vaccine was introduced in 1963, was just 1 dose. In 1989, they started introducing the 2nd dose, recommending the 2 doses. So you can see how people from before 1989 may have gotten only 1 dose and not get updated. Actually, I'm from Portugal. I got the vaccines there, and I think I ended up getting 3 doses. I got the first recommended 1 dose, and then I got after that I got the recommended 2 doses. I'm not an expert on that, but I was curious about it, and I went to read my vaccination records, and from what I could read from the nurse writing, it seems like I got the first 1 dose, and then when the new recommendation came, I got the new 2 doses, the first and the second. Yeah, so it may have happened to people like things like that. So they either get the new recommended doses or not. So yeah, there's probably depends on what people have gotten in the past and what they updated or not. Okay.
Question about what data is available. So you kind of just showed the distribution of people who got measles by the vaccination status.
Yeah.
Do we have data on people's vaccination status so that we could say something like, this was your chance of getting the disease given your vaccination status?
Yeah, that's a good point. So that's why. So you could say, well, if the two doses are 97% effective, then this should only be 3%. But that's not the case because the context is flipped here, right? This is from those who got the vaccine, how many had 1 dose or 2 doses? What you're asking is, from the population, do we have information of how many people got the vaccine, the 1 dose or the 2 doses, so we can do that calculation. I didn't look for that data. I imagine it is available, or it should be probably on the CDC, the Center for Disease Control's website. But yeah, that would be the right way of approaching that question. Nevertheless, this data itself shows that most of the cases were on unvaccinated people. And I didn't look at the data, but generally speaking, the vaccination rates are still high in the US, even though there are spots where it's not as high as they should be to provide herd immunity. Given that they are assumedly high, no, much larger than 50%, then this data itself shows that, you know, there's fewer unvaccinated people, and here there were most of the cases. So it does give you an indication that to answer that question without the whole data. Yeah. All right. So yeah, that's kind of the main point of this is one of the main points of this descriptive analysis. Most of the cases the large majority of the cases were unvaccinated people. The previous point was many of the cases were in children. Actually, again, most of the cases were in children because they are the ones more at risk, because they can only take the vaccines at a certain stages in their at certain stages of their age. And the other point is the outbreak peaked in April. It just so happened in April, the New York City Health Department took stronger actions, and after that it went down. So it's a good indication that the actions they took helped curb the outbreak, even though it's not a causation. You cannot imply causation here, but it's a good indication. Okay, so now the final one. So I'm going to skip this one because the code is the same as one before. Yes?
So from the data that we already have, will we be able to find out that of the people who are unvaccinated, how many of them hadn't reached the age to even get vaccinated? So there was a first dose time, right?
Yeah. So that data is available, and I didn't use that, but that would be kind of a second round of plots that I can create, or anyone can create. So they have this table. They tell you that those so the older ones, most of them didn't know if they were vaccinated or not. Yeah, and so and you'll see the kids will have had vaccinations, and here the older kids, like the teenagers. Sorry, my mistake. Let me correct that. So the kids were not vaccinated as well. So only a few of them had some vaccinations, right? And so across the young ages, you can see that most of the cases did not have the vaccine. And then the older ages, most of the cases, people just didn't know if they had the vaccine or not, because they were old and they didn't know it. So we don't know if they had the vaccine or not. Yeah, so there's still benefit on trying to make a plot of these matrix like that. I made the bar plots just with the totals to highlight the points of the age groups and the vaccination status. but answer detailed questions like that, one could create a matrix plot of this data to highlight that the answers to those questions. All right. So now the map. I'm gonna jump to the code. Okay. So the main library here is bokeh, and as I said, I tried different things. I ended up using bokeh because it let me do what I wanted to do, and it let me save my final result as an image format, PNG and SVG. So let me just restart the kernel to make sure we are good here. So we are importing the libraries. I have a note here about some extra dependencies to use the export functionality in bokeh, but I already included those dependencies in the README file. If you follow those instructions, you should have that already. If not, these are the instructions you should follow to install those dependencies. So the data, again, was the CSV file where I collected the data, but in addition to that, you also need the coordinates data, the latitude and longitude of each neighborhood, so you can place them in the New York City map. And again, it was just a few neighborhoods. I just searched the latitude and longitude and collected it also in the CSV file. So everything is being imported here from CSV files. And done means I found the files and imported them correctly. So the measles data, just having a quick look at the measles data, you'll see you have the neighborhood and the number of cases. I provided here the date information in the column header of the number of cases to keep the context information, so we always know when this data was collected. So we have the neighborhood names. You'll notice that some neighborhoods, some entries in this table have two neighborhoods, like this Brighton Beach and Coney Island. That's because that's how the New York City Health Department reported the data. So I just kept it exactly how they had it. And for the longitude and latitude, because they are different neighborhoods, I just did the average for the neighborhoods. So it was a simple way of representing them in the map. Okay. So in the coordinates data, you have the neighborhoods, and again, you also have the cases like Brighton Beach / Coney Island, and they have the latitudes and longitudes, and these numbers are the averages of these numbers for each of them, Brighton Beach and Coney Island. Okay, as before, we want to keep information about the start months and end months to provide context in our visualization. So because I use this long name here to keep the date information, it's not convenient to refer to this column by this long name when you are doing the coding. So I'm going to rename the columns to some more simple names, to neighborhoods and cases simply. And you can see that now I can even look at all the head. So you have now the column names are neighborhood and cases, so it's easier to refer to the cases column. Again, we extract the totals and we confirm that the totals add up, 649. And at this point, so I have two separate data frames at this point, the number of cases by neighborhood and the longitude and latitude information for each neighborhood. So here I'm merging them in a single data frame so that it's easier when I'm creating the visualization. So I'm using the merge functionality from pandas, merging these two data frames, and now my data frame has the neighborhood, the number of cases, the latitude and longitude for that neighborhood. So bokeh does not use latitude and longitude, at least I couldn't use it. It uses Mercator coordinates, and I found this an initial function that did that conversion. So this is a reference, I think was this function or something similar to this function, and then I modified it to make it more modular for what I needed. So, but this code is inspired by this post here on Stack Exchange, and basically giving a longitude and latitude, it gives you back the corresponding x and y Mercator coordinates, which is what you need to do the plotting with bokeh. Okay, so just define those functions, and for example, New York City's latitude and longitude, you can input that into the Mercator xy function, and it gives you the Mercator xy coordinates. So, because we need that Mercator coordinates, we're gonna introduce that to our data frame. So given the longitude, we can apply the Mercator x function to create the Mercator x coordinates for all the neighborhoods. and the marker y, it's done by applying the marker y function, which needs both latitude and longitude. Okay, so our data frame now has the neighborhood, the cases, latitude, longitude, and marker x and y coordinates. And now that we have all the data we need, we can create the map. And I have several functions here to help creating the map. So as you've seen before, the map has these circles, these bubbles, and I manually define the size of the circles, as I said before, to optimize the space. Oh, okay, let's run the code. There we go. So this is the result. And as I mentioned before, I optimize the size of the circles so that they represent different sizes for different numbers of cases, but also so that they are as large as possible without overlapping each other. And that meant that I defined the sizes manually. It's not like a function, like it's not a linear increase, because if it were, this 473 is much bigger than all the others, just be a big blob over New York City. Or even like trying to do a square root or logarithm, I didn't find any functional expression that would provide a nice representation. So I actually had to do it manually. And so the sizes of the bubbles are defined here. So if the number of cases is smaller than 10, the radius of the bubble is going to be 25. If it's larger than 10 but smaller than 100, it's going to be 35. And if it's larger than 100 and smaller than 200, it's going to be 45. Else, it's going to be 55, which is the only one case, Williamsburg, with most of the cases. So that was a good balance to provide good information in the map. So here it's we're defining a new column in the data frame that is going to have the radius information by applying that function to the number of cases. Now, the label x, this function here, the label x offset, defines where the numbers will be positioned. And again, I had to do manual adjustments to try to make the numbers as right in the center. Okay, so there was quite a lot of manual adjustments to try to make the map and visualization as clean as possible. So here I'm applying the function to the number of cases columns to create the offset for all the neighborhoods. Now here, this was where was even more manual. So if you try to display there's a way to also create an automatic offset for the labels. So for the numbers, relatively easy. You have to put them in the center. You can kind of define a few numbers, and it goes there. But the numbers are kind of be almost all the same for the same cases. You could define an automatic offset for the labels, like always put it on the right. But if I did that, this guy will be on the right, and then this guy will be on the right, and this guy will be on the right. They'll be overlapping each other. So what I did actually, I did individual offsets for each neighborhood, and that's this long manual coding here. Yeah. So for each neighborhood, I am setting so I'm setting the neighborhood, the label x offset and y offset. So these numbers were set by hand so that the labels themselves are placed in the right place and they don't overlap each other, and they don't overlap the other bubbles. So that was some manual work. So this Carto positron retina is the background map. I used that because, as you can see, it's a very neutral background. It provides if you look at it, if people are relatively familiar with the New York City map, they will identify this New York City map. There's New York there. So the background is, I picked this background because it's neutral, and then you can highlight the measles data itself. And okay, well, okay, so at this point you have all the data you need. You just start by providing the background. You create the, yeah, so here it sets the size of the map. Initially create the figure to provide the size of the map. So here I'm just providing the title, and here are those additional notes about the number of cases, about the end of the outbreak, and about the sources. And here I'm just positioning those notes in the right places, like some go above, some go below. Okay. Again, I removed the axis source. This source provides information about the source of the mapping, which is this OpenStreetMap and Car2DB. I also provide in the note, because when you print it as a PNG, that information disappears from the map. Okay. And yeah, so here is how you create the bubbles, the circles, once you have the data ready. Okay. And here's how we add the number of cases, and here's how we add the neighborhood labels. So first I did all the manual work of defining where things are going to be, and then once you have that, you just use the code to show it in the map. And yes, so this could be a dynamic map, interactive map, where you can zoom in and out and move it around. I chose to make it static, because I want people to focus on the neighborhoods where the cases actually happen. If I let the user change the map by zooming in or zooming out or panning left and right, it may just go out of view and then doesn't know how to come back. So in this case, an example of a static image, a static map is better than a dynamic map. Okay, and yeah, so I'm saving the map as SVG and PNG. As I said, the only issue I have at the moment with bokeh is that I cannot easily show the SVG version on a HTML page. When I try to do that, the background tiles of the city map are not showing. So that's something I'm still working on. So that's why I'm using also the PNG version. And yeah, as usual, export that. So that was the bokeh part. And as I said, I present all of this in a dedicated web page, which uses GitHub pages with the defaults. I don't do anything fancy. I know with GitHub pages you can use Jekyll and so on, or Hugo, to make it look more nice and create your own styling. But I just use the plain style. It's all just white, and I provide like textual information as the one that I've been telling you so far, and I define the images with sizes that will show on all the screens, like on the laptop and on the phones. So these are all the images that I've showed you, and like I said, the map is a little more challenging because it's kind of the image that's more wide. So I believe you can still read it on your phone. Maybe a little more challenging than the other ones. Yes. So and that's the final product of all of this. It's the way you present to the general public. In this case, I use a GitHub page because it's very easy. It's very fast to load. Yeah. Do you have any questions? So let me just go back to the beginning. Again, acknowledges to the organization, everyone involved organizing this conference, and thank you for selecting to do this presentation. And again, New York City Health Department for providing the great data. Yeah, I'm open for more questions. Thank you.
Can you
Yes, sorry, since you left, to raise their hand first.
If you had maybe started this project in like March and still wanted to kind of actively track things like the neighborhood where you had to hard code all those things, what kind of approach would you have taken if you wanted it to kind of be an evolving kind of updated map?
Yeah. Oh, an update.
Like if
So
you
yes,
updated it every month
yeah.
to
So
track the progress or something.
I did that. I was doing this while the outbreak was going on, and basically when the New York City Health Department would update the data about once a week. And when they did that, I would update my data and just run the same code and get the new the new map. Yeah. So.
All that hard coding, like,
The neighborhoods don't. Yes. So at some point, the neighborhoods kind of stabilized. They were always the same ones. So if they added a new one, I would have to add a new entry on my CSV file of the neighborhood and the latitude and longitude for it. Yeah. I would have to add the neighborhoods as they added them as well. Yeah. At some point, they did remove some of them. So I have more neighborhoods in my data than there is in the measles data at the moment. Because when it was going on, the data was very preliminary. So they would attribute some cases to some neighborhoods, and then on the next update, they would actually correct to the correct neighborhood. So, yeah, when it was going on, I had, I can quickly show you like some of that data. That data is not inside this dedicated folder for the conference. So everything I showed is in this dedicated folder. But here in the project, there is, so for example, this is the cases by age, and you see the different versions. Oh, let me. So the first version was from, it's always from September 1st when it started to May 20. And then there was an update on May 24th. And so that's also why I have the first columns being the start date and end date. That was the way for me for capturing the different versions as they were updating it. And so I have this for all the data with the different parsed versions. For this talk, I provided only the final version because it's clean and it's less confusing. Yeah, and some of them had to be Excel files like the neighborhoods. So I would have one sheet for each data update. And then when I was loading the data, the sheet had the date of the update, and I would pick the sheet with the latest date. Yeah. Any more questions? Sorry, you were going to ask.
So so if you can recall, what setting did you allow in the repository for GitHub pages to index it directly? So I don't remember top of my head. I can talk with you after to try to give you a reference. But GitHub has an easy reference guide for how to do it. And basically, the way I did it, first I created this github.io. It's kind of your presentation page for GitHub. And after you do that, after you do this one, then when you do a new project, you just go to some settings, which I can show you after, and you just click a button, allow GitHub pages here, and then you just do your github.io / the name of the project, and it points directly to your README or your index.md. So it's easy. So when I create a new project, I will just allow GitHub page here, and I'll have a GitHub page to display as kind of the landing page for the project, more for the general public, like this one. Any more questions? I'll show you the link after. Right. Well, thank you for coming to this 9 a.m. talk.